talk about the type 2 type of eigenvalue questions that the exam questions would normally ask. And this video is a continued version of the type 1. So if you haven't watched the type 1, do please watch. Or if you feel that it's useless, then you just continue here. Okay? And to start off with it, let me rearrange. If you happen that you watch type 1 video, okay, I just simply change this beta to a certain value. I'll just change it to -4, which is what we have found earlier. Okay, for those who have don't know what the hell is beta, I'll just subin it as -4. So hold a while. So when subbing in beta is equals to -4, I will have the full matrix of A. I will assume that you would know how to solve for the general. This is the general method to solve for any eigenvectors. Eigen to solve for any eigenvalues. Okay, and to apply, I will assume that you know how this is being applied. Lambda times the identity matrix minus the A, which is coming from here. Okay, I can also. So I'll just edit a little off, and then I'll just start off with the question itself. So hold on a while. Okay. So once I do that, then the first thing first I need to do is to normally I would set up this equation. If you mentally you know what the hell it is already, you can straight away, the first step is this one. So I can straight away fill in the lambda -2, because this is like simply taking this equation, that's all. So lambda -2, lambda -1, and so on and so forth. If you happen that you watch my last video, if you haven't watched, I would normally recommend you can fill out firstly you can fill out the diagonal one, and then you fill in the values over here. These are the values that are not diagonals, and then you simply change their sign from minus. If it's minus, you change to plus. If it's plus, you change to minus, and things like that. Alright, so what I've done is, therefore, if I were to bring it up here, so for example, -2 I change to +2, +2 I change to -2, and then 1 change to -1. Reason is because lambda I minus A, right? Lambda I minus A, which is this A, right? So when it's minus, let's say -2, I have +2 over here. That's the meaning of it. Okay, it's just the math. If when you start doing, you know what I mean. But anyway, so in order to find the rest of the eigenvalue, so now the question not solve for beta anymore. So it asks you to find the rest of the eigenvalues. Okay, solve for the eigenvalues. Now, typical 3 by 3 matrix will give you 3 values of eigenvalues. So in this case, they have kindly given you one of the eigenvalue. So later on, you know how this can help you in solving your stuffs, right? So what I can do right now at this portion of time is to do up what I've said earlier, the rules of Saurus. Okay, if you watch my last video, you know what the hell am I talking. If you don't know, if you haven't watched my last video, I'll just quickly chop go through, and then the rest is yeah. So what I do now is the rules of Saurus states that you take the orange colors, you multiply them together, minus away the blue colors one, the sum of the blue color. So I would have, so this is a very tedious part where careless mistakes always goes wrong over here. So be very careful when you are doing this things, right? So I have this thing plus the second I will assume the diagonal row. So 2 minus 1 minus 4, I would have 8, right? Plus -2 times 0, which is 0. This whole thing, and then minus, what the hell am I doing? Minus away the blue color, the sum of the blue colors. So -2 times -4 is 8. So I would have 8 lambda minus 1, okay, plus sum of the rest. So I have also 8 lambda minus 2, and then anything times 0 is actually 0, so I have plus 0. And so therefore we have this thing equals to 0 definitely. Okay, equals to 0. So now we're gonna expand this whole piece of things. Alright. So again, if you feel that expanding this is actually easy, you can actually skip to the further part, okay, of this video, maybe it's about 2 or 3 minutes later. Otherwise, if you don't know what the hell I'm gonna do next, then stay on. Alright. So what I'm gonna do is to multiply in all this. Okay, so I'll multiply this. I will assume that you have remember. If you don't remember, I can just recap. So lambda times lambda, I have lambda square. Lambda times minus lambda, I have minus lambda. Then after that I will elaborate. So this term multiplied by each of this term, and then this term multiplied by, I think you get what I mean already. So minus 2 times that lambda, so I have, and then minus 2 times minus 1, I have plus 2, right? And then I can solve for this thing, right? So I do the same thing. So one term times 2 of these terms, another term times 2 of this term, but I see that there is minus lambda and minus 2 lambda, they have the same coefficient, so I can actually stream them into minus 3 lambda, right? Okay, so what I'm gonna do is to do the same thing. So lambda square times lambda is lambda cubed. Lambda square times minus 3 is minus 3 lambda square. And then minus 3 lambda times lambda, it's minus 3 lambda square. And then minus 3 lambda times minus 3 is plus 9 lambda. And then 2 times lambda is 2 lambda. And then 2 times minus 3 is minus 6. Right? So if you, I would recommend you double check again. Okay? So this is the portion where always careless mistakes will go wrong over here. So please double check. So for me, I'll double check. So you pause the video a while. I'll pause the whole one. I would assume that I am on the right track. So let's continue. Right. So okay. So now I'm gonna elaborate the blue color one. Okay. So never mind. I'll to use the same color again. And then I elaborate this part. Okay, where am I? Okay, so 8 lambda, so I multiply in the 8 into this thing, so I will have, be very careful of this, of the sign. So 8 lambda and then minus 8, right, plus, so this whole thing is a big bracket actually, right, and then 8 lambda, okay, 8 times minus 2, I have minus 16, okay, and let's do some sortings. Alright, let's do some sortings. And I assume you are feeling bored, so I'll just do it myself. Before I do it myself, I would urge that you be very careful of this negative sign. Okay, be very careful. You're gonna multiply it into each of these terms. Alright, because this minus is to the sum of the whole blue color stuffs. Alright, so when I were to input this minus into them, I will have minus 8 lambda plus 8 minus 8 lambda minus 16, I have plus 16. Okay, so I'm gonna somewhat reorganize them. So this is the part where I think is boring for you, so I'll just do it myself. I got an answer like this, and it's actually wrong. Why am I wrong? Okay, I'm gonna tell you where's my careless mistake. Remember, when I sub in my beta as minus 4, at the very, if you forget, you just go to the first 1 minute or 2 minutes. You can just check it out. Okay, when I sub in beta is equals to minus 4, okay, I should also minus 4, right? If you remember, this is minus 4. If I were to change, minus 2 will change to plus 2, plus 2 will change to minus 2, but minus 4 I didn't change to plus 4. So this is the place where I've gone wrong, right? So somewhat you can ignore this thing. Okay, I don't know whether you're gonna do this or not, but you can somewhat ignore. If you are doing this, you can add as a reference, but be careful of the plus 4 over here. And definitely I already know the answer, so I'm not gonna carry on with this this big tick thing. Alright, so I'll just straight away jump to the conclusion of the answer. So okay, so after I do all this, okay, generally, sorry, I'm lagging. So generally, this is not the steps that I'm taking, but it's the same. Okay, it's just that I didn't do this because I know the answer. I straight away sub it in over here. I just tell you this is my answer. Okay, so these workings are unrelated. I'm lagging. These workings are unrelated to my answer over here, but this is the answer generally. Okay, so once you get this answer, how are you going to solve for the other two eigenvalues that I've mentioned earlier? Alright, because in the question they already tell you that one of the possible eigenvalue is 3. So how do you solve for the rest? The most highest recommendations I'll recommend you is to go and buy a calculator and then go and search for third order equation solver calculator YouTube, and then the YouTube they will actually teach you how to solve all it. And generally I'm using Casio, so I think Casio is good, and you see everything is about Casio, so I think Casio is a good calculator. And please buy something like a series that is somewhat of this type. Okay, it's very good and it's really helpful for if you are studying engineering. So this is a very good calculator that I would highly recommend. Okay, yeah. So if you use this calculator and then you solve for it, the calculator teach you, you'll get eventually some answers. But let's say if you do have this type of calculator and in the test you accidentally lost your calculator or don't know what the hell has gone wrong, sadly, what can you do about it? So I will introduce you with syntactic divisions. Syntactic division. Okay. So how the hell can I do with this? Syntactic division, I'll just take out all the coefficients of my stuffs, right? 1, -6, 11, and -6. Draw something like this. And we know that we have our eigenvalue, one of our eigenvalue is 3, right? So we can simply sub it in. Okay, we sub it in over here. Hold on a while, I double check. It should be fine. So the first step I need to do for syntactic divisions, okay, if you can also search for internet if you want to find out more, okay, it's something like this. So it's similar to what I'm doing right now. And therefore the first step I need to do is to actually put this first coefficient down at here first. And then I multiply with 3, okay, 3 times 1 is 3. So you put your eigenvalue over here, okay. So you put your, okay, anyway, so 1 times 3 is 3, and then I sum it up together, -6 plus 3, I have -3, and then I use this one, I multiply with this again, 3 times -3, what I have is -9, right? So -9 plus 11, I will have 2, okay? Then 3 times 2, I have 6, -6 times 6 is equals to 0. Ensure that this is equals to 0. This must be equals to 0. Okay, this must be equals to 0. And hence, we can translate this dude over here as a second order system, which is what I'm writing right now. Okay, so this is simply saying that its remainder is equal to, okay, no, not that meaning, okay, anyway. So yeah, the remainder must be equals to 0. If it's not 0, okay, if some values, this means that your eigenvalue is not correct. Okay, let's say for example they didn't give you your eigenvalue. Let's say they are not very kind, they actually didn't give you, alright, they say solve for the lambda values, then you're gonna guess. Then when you guess and your remainder is not 0, then you have to guess a different numbers, okay, until you're happy lah. Okay, but generally I will not I recommend you use calculator lah. That's the highest recommendations I will recommend. And then once you were to solve for this, I would think that you know how to solve for this. okay, never mind, let's do together, lambda lambda, and then I take the coefficient, okay, 2 and 1, okay. I know that this is negative, so I can just take this as negatives, and then I'll have lambda minus 2 and lambda minus 1. And I also know that I have my roots as lambda minus 3. So lambda is equals to 3, 2 and 1. Alright? So the roots is 3 is because the roots, okay, the roots, what it means is that what makes this thing equals to 0. If lambda is 3, then 3 minus 3 is equals to 0. So this is the meaning of the roots. So you're gonna find, normally they when they say roots, it means this values over here. So be very careful. And these roots will make the equation equals to 0. So once you have that root, you will know that this is your value that you want. Okay. So you need to be very clear what values you're gonna put it in. Alright. So this is the values that I'm talking about. These are the eigenvalues. Okay. So if you don't know anything along the way, you can actually head back to the few minutes ago. You can just look through this video again and then be familiarized with yourself. And yeah, so this ends the type 2 eigen exam questions, and then later on we'll deal with the type 3s. Alright, I shall see you there.